The humid air hung thick in the Amazon rainforest as Dr. Elena Vasquez carefully brushed dirt away from what appeared to be a metallic surface buried deep beneath layers of sediment that carbon dating suggested were at least 65 million years old. Her hands trembled slightly as she worked, not from fatigue, but from the growing realization that what she was uncovering might fundamentally challenge everything humanity believed about its place in Earth's history. The object beneath her tools was clearly artificial, its surface bearing geometric patterns that seemed almost familiar yet impossibly ancient. Predating the emergence of Homo sapiens by tens of millions of years, as she worked, Elena couldn't shake the feeling that she was not discovering something new, but rather rediscovering something that had been deliberately hidden or forgotten. Something that suggested humanity might not be the first intelligent species to call Earth home. The concept that we might not be the first civilization on Earth is one that has fascinated scientists, philosophers, and storytellers for generations. Yet it remains largely relegated to the realm of speculation and science fiction, rather than serious academic inquiry. However, when we begin to examine the evidence with fresh eyes and consider the vast timescales involved in Earth's history, the possibility becomes not just plausible, but perhaps even probable. Earth is approximately 4.6 billion years old, and complex life has existed for hundreds of millions of years, while human civilization as we know it spans merely the last 10,000 years or so. This represents an almost incomprehensibly tiny fraction of Earth's total history, leaving vast periods during which other intelligent species could have risen, flourished, and disappeared without leaving obvious traces for us to discover. The challenge in detecting evidence of previous civilizations lies not in the improbability of their existence, but rather in the nature of geological time and the Earth's remarkable ability to recycle and transform its surface materials. Consider how little of our own civilization would survive if humanity disappeared tomorrow. Most of our cities, roads, and structures would be reduced to unrecognizable rubble within mere centuries. All the organic materials that make up so much of our technology would decay completely within millennia. Only the most durable materials like ceramics, certain plastics, and perhaps some nuclear waste would persist for hundreds of thousands of years, and even these would eventually succumb to the relentless processes of erosion, sedimentation, and tectonic activity that constantly reshape Earth's surface. The fossil record, while extensive, represents only a tiny fraction of all life that has ever existed on Earth, with fossilization requiring very specific conditions that preserve organic material before it can decompose. The vast majority of organisms that have lived and died on our planet have left no trace whatsoever, their remains consumed by bacteria, scattered by wind and water, or simply crushed and recycled by geological processes. If this is true for simple organisms whose bones and shells are relatively durable, how much more difficult would it be to detect evidence of a civilization that might have been based on organic technologies, biodegradable materials, or energy sources that leave no lasting geological signature? Dr. Vasquez's discovery in the Amazon was just one of several anomalous findings that had begun to surface in recent years, each one individually explicable but collectively forming a pattern that suggested something extraordinary. In the Australian outback, geologists had found metallic spheres embedded in rock formations that predated complex life on Earth. Their composition, unlike any known natural mineral, and their perfect spherical shape defying explanation. Deep ocean surveys had revealed geometric structures on the seafloor that appeared to be too regular to be natural formations, yet were buried beneath sediments that suggested they were millions of years old. Most intriguingly, ice core samples from Antarctica had revealed microscopic particles of materials that shouldn't exist in nature, concentrated in layers that corresponded to mass extinction events in Earth's distant past. The Silurian Hypothesis, proposed by astrophysicist Gavin Schmidt and astrobiologist Adam Frank, provides a scientific framework for considering what traces a previous industrial civilization might leave behind and how we might detect them. named after a fictional race of intelligent reptiles from the British science fiction series Doctor Who. The hypothesis examines what geological signatures our own civilization will leave behind and extrapolates from this to consider what we might look for when searching for evidence of previous civilizations. The researchers found that while direct artifacts of a civilization might disappear relatively quickly, the chemical and isotopic signatures of industrial activity could persist in the geological record for much longer periods. Our own civilization has already begun to leave distinctive chemical fingerprints in Earth's geological layers through the burning of fossil fuels, the production of synthetic materials, and the detonation of nuclear weapons. The carbon isotope ratios in ice cores and sediments clearly show the impact of industrial activity beginning around 1850, while the presence of artificial radionuclides marks the beginning of the nuclear age in the 1940s. These signatures will remain detectable in the geological record for millions of years, long after all physical traces of our cities and technologies have disappeared. Similarly, a previous civilization might have left similar chemical fingerprints that we have simply not yet learned to recognize or have misinterpreted as natural phenomena. The concept becomes even more intriguing when we consider the possibility that previous civilizations might have developed along entirely different technological pathways than our own. Human civilization has been built largely on the exploitation of fossil fuels and mineral resources, but an intelligent species that evolved in a different environment or under different circumstances might have developed biotechnology, energy sources based on biological processes, or material science approaches that we can barely imagine. Such a civilization might have achieved remarkable technological sophistication while leaving virtually no trace that our current scientific methods would recognize as artificial. Consider the possibility of a civilization that developed during one of Earth's previous warm periods, perhaps the Paleocene-Eocene thermal maximum around 55 million years ago, when global temperatures were much higher than today and tropical conditions extended almost to the poles. Such a civilization might have been based entirely on biological technologies, using engineered organisms for manufacturing, construction, and energy production. Their cities might have been living ecosystems, their transportation systems based on trained or engineered creatures, their information storage and processing accomplished through biological networks, rather than electronic computers. When such a civilization ended, either through natural catastrophe or their own choices, virtually all evidence of their existence would have decomposed and returned to the natural ecosystem within thousands of years. The mathematical probability of such scenarios becomes apparent when we consider the Drake equation, originally formulated to estimate the likelihood of extraterrestrial civilizations, but equally applicable to the possibility of previous terrestrial civilizations. The equation considers factors such as the number of suitable planets, the likelihood of life developing, the probability of intelligence emerging, and the duration of technological civilizations. When applied to Earth's history, with its billions of years of stable conditions and multiple periods suitable for complex life, the equation suggests that the development of multiple intelligent civilizations over geological time is not just possible but statistically likely. The Fermi paradox, which questions why we haven't encountered evidence of extraterrestrial civilizations despite the apparent likelihood of their existence, might find its answer not in the stars, but in our own planet's history. Perhaps the reason we haven't detected alien civilizations is that intelligence has a tendency to arise and disappear on relatively short timescales, leaving little trace for subsequent civilizations to discover. If this pattern holds true throughout the universe, then the apparent absence of detectable alien civilizations might simply reflect the difficulty of detecting the faint traces that intelligence leaves behind rather than the absence of intelligence itself. Dr. Vasquez's team had spent 3 years analyzing their Amazon discovery, subjecting the metallic artifact to every conceivable test in an attempt to determine its origin and age. The material itself was unlike anything in the periodic table, appearing to be a metallic glass with properties that current materials science couldn't fully explain. The geometric patterns on its surface showed mathematical relationships that were sophisticated yet different from human mathematical conventions, suggesting a different approach to understanding spatial relationships and numerical concepts. Most remarkably, the artifact appeared to contain internal structures visible only through advanced imaging techniques, revealing what looked like circuits or pathways that followed no known principles of electronics or engineering. The implications of such discoveries extend far beyond mere historical curiosity and touch on fundamental questions about the nature of intelligence, civilization, and our place in the cosmos. If humanity is indeed not the first intelligent species to evolve on Earth, then we are part of a longer continuum of consciousness and creativity that stretches back through geological time. This perspective radically alters our understanding of human uniqueness and might provide valuable insights into the challenges that all intelligent civilizations face, including our own current crisis of environmental destruction, resource depletion, and social fragmentation. Previous civilizations on Earth might have faced and solved problems that currently perplex humanity, developing sustainable technologies, social organizations, or philosophical frameworks that allowed them to thrive for millions of years before eventually choosing to transform themselves in ways that left no recognizable traces. Alternatively, they might have made mistakes that led to their disappearance, providing cautionary examples that could help humanity avoid similar fates. The study of hypothetical previous civilizations thus becomes not just an exercise in paleontology or archaeology, but a form of applied philosophy that might help us navigate our own civilization's future development. The search for evidence of previous civilizations also requires us to reconsider our assumptions about what constitutes intelligence and what forms civilization might take. Human civilization is characterized by tool use, language, social organization, and the manipulation of the environment on a large scale. But these characteristics might not be universal features of all intelligent species. An aquatic civilization might develop entirely different technologies based on hydrodynamics and biochemistry, while a species that evolved in underground environments might create architectural and engineering marvels that exist entirely below the surface where we would never think to look for them. The temporal aspect of this question adds another layer of complexity, as the Earth's surface has been completely renewed multiple times through the action of plate tectonics, erosion, and sedimentation. The oldest rocks on Earth's surface are less than 4 billion years old, while the planet itself is 4.6 billion years old, meaning that any evidence of extremely ancient civilizations would have been literally recycled through the Earth's geological processes. Even evidence from more recent periods might be hidden beneath layers of sediment or transformed beyond recognition through metamorphic processes. Climate change and geological catastrophes provide natural endpoints that could explain the disappearance of previous civilizations without requiring them to have destroyed themselves through warfare or environmental destruction. The Earth has experienced numerous mass extinction events throughout its history, from asteroid impacts to massive volcanic eruptions to sudden climate shifts that radically altered the planet's environment. Any civilization unlucky enough to exist during one of these events might have been wiped out regardless of their technological sophistication or wisdom, leaving only the faintest traces of their existence for future archaeologists to puzzle over. The KT extinction event that ended the age of dinosaurs 65 million years ago represents perhaps the most dramatic example of how quickly and completely a catastrophic event can reset the biological clock on our planet. If an intelligent civilization existed during the Mesozoic era, perhaps descended from some branch of dinosaur evolution that developed enhanced cognitive abilities, they might have achieved remarkable sophistication only to be completely eliminated by the asteroid impact that marked the end of their age. The geological violence of such an event would have obliterated virtually all traces of their existence, burying any artifacts beneath layers of impact debris and fundamentally altering the chemical composition of the planet's surface. Yet even such catastrophic events might leave subtle clues for careful observers to discover. The boundary layer that marks the KT extinction is characterized by elevated levels of iridium and other rare elements, creating a distinctive signature that geologists can identify around the world. A civilization facing such a catastrophe might have attempted to preserve some record of their existence, perhaps by creating artifacts designed to survive geological catastrophes, or by encoding information in forms that would remain stable over geological time. Such efforts might have left traces that we have encountered but not recognized, interpreting them as natural phenomena rather than the deliberate creations of intelligence. Dr. Vasquez often found herself wondering about the beings who might have created the artifact she had discovered, trying to imagine what their society might have been like and what circumstances might have led to their disappearance. The mathematical relationships encoded in the artifact's surface patterns suggested a species with a sophisticated understanding of geometry and number theory, while the unusual material properties indicated advanced materials science capabilities. Yet the artifact's location deep in what was now rainforest suggested that their civilization had been located in an entirely different environment, perhaps during a period when the Amazon basin was covered by ocean, or had a completely different climate. The possibility that multiple civilizations might have risen and fallen on Earth throughout its history raises fascinating questions about whether they might have been aware of each other or even learned from each other's remains. Perhaps the artifacts and traces of the first civilization were discovered by the second, providing them with technological insights or philosophical perspectives that shaped their own development. This could have created a form of civilizational evolution, with each successive intelligent species building on the achievements of their predecessors while avoiding their mistakes. Such a scenario might explain some of the puzzling aspects of human development, including the apparent speed with which our species progressed from hunter-gatherer societies to complex civilizations. While conventional archaeology attributes this rapid development to the invention of agriculture and writing, it's possible that early humans discovered and learned from artifacts left by previous civilizations, gaining insights that accelerated their own technological and social development. This could explain some of the mysterious megalithic structures found around the world, which seem to demonstrate engineering capabilities that exceed what we would expect from the societies traditionally credited with building them. The engineering techniques used to construct structures like Puma Punku in Bolivia, the pyramids of Giza in Egypt, or the massive stone blocks at Baalbek in Lebanon continue to puzzle archaeologists and engineers, who struggle to explain how ancient societies with supposedly primitive tools could have achieved such precision and moved such enormous weights. While conventional explanations focus on lost techniques and sophisticated understanding of leverage and mathematics, an alternative possibility is that these structures incorporate knowledge or even actual components salvaged from much earlier civilizations. The astronomical alignments found in many ancient structures worldwide suggest that their builders possessed sophisticated knowledge of celestial mechanics and long-term astronomical cycles. While this knowledge could have been developed through careful observation over many generations, it might also represent information preserved from an earlier civilization that had achieved a more advanced understanding of astronomy and mathematics. The apparent global distribution of certain architectural techniques and astronomical knowledge might reflect not just independent development or cultural diffusion, but rather the rediscovery and reinterpretation of information left by a previous global civilization. Religious and mythological traditions from around the world contain remarkably consistent themes about golden ages, lost civilizations, and advanced beings who shared knowledge with early humans before disappearing. While these stories are typically interpreted as metaphorical or symbolic, they might represent cultural memories of actual encounters with the remnants of previous civilizations or with artifacts and information left behind by them. The universal nature of flood myths, for example, might reflect not just local experiences with natural disasters, but cultural memories of global catastrophes that ended previous civilizations. The Hindu concept of cyclical time, with its vast cosmic cycles during which civilizations rise and fall repeatedly, provides one of the most explicit frameworks for understanding human history as part of a much longer pattern of civilizational development. According to these traditions, we are currently living in the Kali Yuga, the last and most degenerate phase of a cosmic cycle that began with a golden age of perfect civilization. While Western thought has traditionally viewed history as linear progress from primitive to advanced states, the Hindu perspective suggests that we might actually be in a period of decline from much higher previous achievements. Similar concepts appear in other ancient traditions, from the Greek notion of golden, silver, bronze, and iron ages to the Aztec belief in multiple previous worlds that were destroyed and recreated. The consistency of these themes across cultures that had no known contact with each other suggests that they might be based on something more than mere imagination or philosophical speculation. They could represent fragmented memories of actual historical events, preserved through oral tradition across thousands of generations. The technological signatures that previous civilizations might have left behind could take forms that we haven't yet learned to recognize, or have misinterpreted as natural phenomena. For example, certain mineral deposits might represent the remains of industrial processes, rather than natural geological formations, while unusual isotope ratios in ancient rocks might indicate artificial nuclear reactions, rather than natural radioactive decay. This search for such signatures requires us to approach familiar geological and archaeological evidence with fresh perspectives, looking for patterns that might indicate intelligence even when they don't conform to our expectations about what artificial structures should look like. Dr. Vasquez's discovery had sparked a small revolution in how scientists approached anomalous findings, encouraging them to consider artificial origins for phenomena that had previously been dismissed as natural curiosities. Teams of researchers had begun re-examining museum collections and geological surveys, looking for objects and formations that showed signs of intelligent design or artificial modification. The results had been surprising, with several previously cataloged natural specimens showing geometric regularities, unusual material properties, or isotopic compositions that suggested artificial origins. One particularly intriguing finding came from deep-sea core samples taken from the Pacific Ocean floor, which revealed layers of sediment containing microscopic spheres of unusual metals arranged in complex geometric patterns. The spheres were too perfect to be natural formations and were composed of alloys that don't occur naturally on Earth, yet they were embedded in sediment layers that radiocarbon dating placed at over 2 million years old. The regular spacing and geometric arrangement of the spheres suggested that they might be components of some kind of technology, perhaps computing or data storage devices that had survived the decay of whatever larger system they once belonged to. Another significant discovery came from analysis of Antarctic ice cores, which revealed the presence of artificial compounds embedded in ice layers that dated to several 100,000 years ago. These compounds appeared to be synthetic polymers similar to modern plastics, but with molecular structures that were more stable and sophisticated than anything current chemistry could produce. The concentration of these materials in specific ice layers suggested that they might represent the remains of a civilization that achieved advanced materials science before disappearing during one of the ice ages that periodically engulfed the planet. The implications of such discoveries extend beyond mere historical interest and raise profound questions about the relationship between intelligence and environmental sustainability. If previous civilizations did exist and subsequently disappear, understanding the causes of their demise might provide crucial insights for our own civilization's survival. Did they destroy themselves through warfare, environmental destruction, or resource depletion? Or were they eliminated by natural catastrophes beyond their control? The answers to these questions could help humanity make better decisions about our own technological development and environmental management. The possibility that previous civilizations might have achieved sustainable relationships with their environment offers hope that such solutions are possible, while the evidence of their eventual disappearance serves as a sobering reminder that even successful civilizations are not guaranteed eternal survival. Perhaps the key to long-term civilizational survival lies not in achieving technological mastery over the environment, but in learning to integrate seamlessly with natural systems in ways that enhance rather than degrade the planet's ecological stability. Some researchers have speculated that previous civilizations might have deliberately chosen to abandon physical technology in favor of biological or consciousness-based approaches to organizing their societies. Such a choice might reflect a mature understanding of the limitations and dangers of industrial civilization, leading to a conscious decision to return to more sustainable ways of life that left minimal traces for future archaeologists to discover. This possibility challenges our assumptions about progress and development, suggesting that the abandonment of technology might sometimes represent wisdom rather than failure. The search for evidence of previous civilizations has been complicated by the fact that our own scientific methods and instruments are designed to detect and analyze phenomena that conform to our current understanding of chemistry, physics, and engineering. Technologies based on different principles or unknown scientific laws might be literally invisible to our current detection methods, existing all around us without our awareness. This limitation suggests that the absence of evidence for previous civilizations might reflect the inadequacy of our search methods rather than the absence of the civilizations themselves. Advanced civilizations might have developed technologies that operated at quantum scales or utilized principles of physics that we haven't yet discovered, making their artifacts as incomprehensible to us as a computer would be to a medieval scholar. The geometric patterns on Dr. Vasquez's artifact, for example, might represent information encoding systems or technological principles that are so far beyond our current understanding that we can recognize their artificial nature without being able to comprehend their purpose or function. The concept of technological paradigms suggests that each civilization might develop along unique technological pathways that reflect their environment, biology, and cultural values. While human civilization has been built on the manipulation of metals, silicon, and fossil fuels, an aquatic civilization might have developed biotechnology based on engineered algae and marine organisms, while a subterranean species might have mastered geothermal energy and crystal-based information processing. Such civilizations might have achieved capabilities that far exceed our own, while using methods that we wouldn't recognize as technology at all. The temporal dimension of this question becomes even more complex when we consider that intelligence itself might operate according to different timescales than we typically assume. Human consciousness operates on timescales of seconds to decades, but a truly advanced civilization might have developed forms of intelligence that think and act on geological timescales, planning and executing projects that span millions of years. Such beings might still exist around us, carrying out incomprehensibly long-term projects that we interpret as natural processes because we can't perceive the intelligence behind them. This possibility opens up speculative but scientifically grounded scenarios in which previous civilizations might have transformed themselves rather than simply disappearing, perhaps uploading their consciousness into planetary-scale computing systems or merging with natural processes in ways that allowed them to survive while becoming undetectable to surface-dwelling intelligences like ourselves. The apparent intelligence displayed by some ecological systems, with their complex feedback mechanisms and adaptive responses, might represent not just evolutionary optimization, but actual designed intelligence operating at scales we can barely comprehend. Dr. Vasquez had begun to suspect that her Amazon discovery might be just the tip of an iceberg, with much more evidence waiting to be found by researchers who knew what to look for and how to interpret it. He had started collaborating with specialists in unusual materials, xenorchaeology, and even consciousness research, building an interdisciplinary team capable of approaching the question from multiple angles. Their preliminary findings suggested that evidence of previous civilizations might be much more common than previously thought, hidden in plain sight within geological formations, mineral deposits, and even biological systems that had been misunderstood or overlooked by conventional science. The team had developed new analytical techniques specifically designed to detect artificial modifications in natural systems, looking for patterns of organization, material properties, or information content that exceeded what should be possible through natural processes alone. These methods had already yielded surprising results, identifying potentially artificial structures in everything from crystal formations to bacterial colonies to the organization of certain ecosystem networks. While each individual finding could potentially be explained through natural processes, the accumulating evidence suggested a pattern of intelligence that had been active on Earth for much longer than human civilization had existed. One of the most intriguing discoveries came from analysis of certain plant and animal species that showed genetic modifications too sophisticated and purposeful to be explained by natural evolution alone. These modifications appeared to be designed to enhance the organism's ability to process information, communicate over long distances, or manipulate their environment in subtle but significant ways. The changes were so seamlessly integrated into the organism's natural biology that they had been overlooked by generations of biologists who assumed they were natural adaptations rather than artificial enhancements. The implications of such findings suggested that previous civilizations might have taken a fundamentally different approach to technology, choosing to work with and enhance natural systems rather than replacing them with artificial alternatives. This biotechnological approach might have allowed them to achieve remarkable capabilities while maintaining ecological sustainability, avoiding the environmental destruction that characterizes our own industrial civilization. The organisms they modified might still be living among us today, carrying out their original functions while appearing to be nothing more than natural wildlife. This possibility raised profound questions about the boundaries between natural and artificial, challenging our assumptions about what constitutes technology and intelligence. If previous civilizations had achieved seamless integration with natural systems, then the distinction between their artifacts and natural phenomena might be meaningless, with the entire biosphere potentially representing a vast technological system designed and maintained by intelligence operating at scales we can barely imagine. The philosophical implications of these possibilities extend far beyond science and touch on fundamental questions about consciousness, identity, and humanity's relationship with the natural world. If we are indeed not the first civilization on Earth, then our current environmental crisis might be viewed not as an unprecedented catastrophe, but as a familiar pattern that intelligence faces when it first develops industrial capabilities. Previous civilizations might have faced similar challenges, and either found solutions that allowed them to transcend physical technology entirely or failed to adapt and disappeared as a result. The knowledge that other intelligences had walked this path before us might provide both hope and caution, suggesting that solutions exist while warning about the consequences of failure. Perhaps the traces of previous civilizations that we are beginning to discover represent not just historical curiosities, but actual messages left behind as guidance for future intelligences that would face similar challenges. The geometric patterns on Dr. Vasquez's artifact might encode not just mathematical relationships but practical information about sustainable technology, social organization, or consciousness development that could help humanity navigate its own evolutionary challenges. The search for evidence of previous civilizations thus becomes more than an academic exercise, transforming into a practical investigation that might yield insights crucial for our own survival and development. Each new discovery provides another piece of a vast puzzle that, when assembled, might reveal not just the history of intelligence on Earth, but a roadmap for its future development. The question of whether we are the first civilization on Earth ultimately becomes inseparable from questions about where we are heading and what choices we need to make to ensure our own long-term survival. As Dr. Vasquez continued her work in the humid depths of the Amazon rainforest, carefully excavating more artifacts from the ancient sediment layers, she realized that she was not just uncovering the past, but potentially discovering keys to the future. Each new finding added to a growing body of evidence that intelligence on Earth was far older and more complex than anyone had imagined. with implications that would fundamentally change how humanity understood its place in the cosmic story of consciousness and creativity. The metallic artifact in her hands might represent not just proof of previous civilizations, but a bridge between past and future intelligence that could help guide humanity toward its own transformation and transcendence. The ongoing research into previous civilizations has begun to yield insights that go far beyond simple historical discovery, revealing patterns and principles that might govern the development of all technological civilizations regardless of their specific biological or cultural characteristics. These findings suggest that intelligence itself might follow certain evolutionary pathways that lead through predictable stages of development, from the initial emergence of consciousness through the development of technology and social organization to eventual transcendence or transformation beyond the need for physical artifacts and structures. Understanding these patterns could help humanity anticipate and prepare for the challenges and opportunities that lie ahead in our own civilizational development, potentially allowing us to avoid the mistakes that led to the disappearance of our predecessors while building on their achievements and insights. The question of whether we are the first civilization on Earth thus becomes not just a matter of historical curiosity, but a crucial investigation into the nature of intelligence itself and the possibilities that await all conscious beings as they evolve toward greater understanding and capability. The evidence continues to accumulate hidden in geological formations, embedded in biological systems, and encoded in the very structure of the world around us, waiting for humanity to develop the wisdom and sophistication necessary to recognize and interpret it. As we continue to search for traces of those who came before us, we simultaneously prepare ourselves for the transformations that may await us, learning from the past while building toward a future that honors both the achievements and the mysteries of intelligence on Earth.